Okay, I attempted to record what I did in second period yesterday, but for some reason the audio cut out after about 5 minutes, and then it was like 20 minutes of silence just watching the videos. So, gonna give this another shot, which is unfortunate because second period had a lot of fun saying things to y'all and being silly and stupid all at the same time. But oh well. So this is what we've got. Um, Y'all's homework last night, which y'all may not have done because you knew you weren't going to see me tonight or today. But there were some problems on graphing log functions, and I never showed you how to do that. So if you attempted the homework, you should not have known how to do the graphing ones. As far as the homework answers, if you go to my webpage, click on notes, go to October. Oh man, it's not on there yet because I haven't uploaded it. But if you'll click on October 19th, and the answers to y'all's homework are actually on my webpage. I'm pretty sure that I copied them on there. So you can go to my webpage, click on the notes, and you can see the answers to last night's homework to help you along. And then I'll answer specific questions on Monday when I return. But to graph logs, what I'm going to do is just kind of show you real quick how you can figure it out. And I'm going to start by actually graphing this one. Uh-oh, I lost it. I'm going to start by graphing number 4, y equals log base 4 of x. And the way we'll do that, actually I guess I can do it right here. The way we'll do that is I'm going to take that out of log form, and it can be rewritten as 4 to the y is equal to x. And then to figure out what the graph looks like, we could just create a good old xy table. I'm trying to draw here. Thank you. I could create an xy table, and it's going to be a little bit backwards, but instead of plugging numbers in for x, I'm actually going to plug in numbers for y, because I can do 4 to the whatever power pretty easily. So I'm going to actually plug in numbers for y. So if I plug in 0, 4 to the 0 gives me an x of 1. If I plugged in 1, 4 to the first is 4. If I plugged in 2, 4 squared is 16. And now I'm going to start getting pretty large x coordinates. If I plugged in negative 1, 4 to the negative 1 is 1 over 4. And what this does is it gives me a few points that I can plot. So I have the ordered pair 1, 0. So I'll plot 1, 0. Ordered pair 4, 1. 16, 2 is going to be way off the graph, so I'm not going to worry about that. Then 1/4 negative 1 is going to be about right here. And what this graph ends up doing is it comes up along the y-axis. It goes through the ordered pair 1, 0, and then it starts to kind of level off as it goes to the right. And it does have a vertical asymptote on the y-axis right there. So that's how we're going to graph log functions. Now, one thing that could speed it up, and these are the blanks up here, a log function, if it's log base b of x, they're always going to go through the ordered pair 1, 0, which this one did, and they will always go through whatever the base is, 1, which this one did. The base was 4, so it went through 4, 1, which that one did. And then it has a vertical asymptote at, and that is at x equals 0, which is the same thing as the y-axis. So logarithmic graphs, they go through 1, 0, whatever the base is, 1, and then you use the y-axis as an asymptote. So if I'm graphing ln of x, now remember ln is the same thing as log base e, which you don't have to write that, but they'll go through the ordered pair 1, 0, and e1. Now remember e is approximately 2.7 and a bunch of other stuff. So 12.71. And then you have a vertical asymptote on the y-axis. And we'll graph that. Just kind of follow along. Follow along. It's going to come up. It'll go through 1, 0, whatever the base is, 1, and then it'll keep going that way. So that's how we're going to graph logarithmic functions. Now keep in mind, just like everything else, this can change based on transformations. But if it's not transformed, just your basic log graphs goes through those 2 points and has an asymptote on the y-axis. What would help is if we could identify transformations and the parent function. So let's do, maybe not do all 3 of these, but maybe numbers 3 and 5. Let's do numbers 3 and 5. Looking at 3, the parent function, if you stripped away all transformations, you'll be left with just y equals log base 2 of x. And I know that that would pass through the points 1, 0, and 2, 1. That's where I would start. Then you have your vertical asymptote on the y-axis. Then I need to transform it, and I see 2 transformations. I'm looking at this, and I see a plus 4 on the outside, and then I see a minus 1 on the inside. Okay, so that minus 1 and plus 4, the minus 1 and the plus 4, if it's inside with the x, that affects the x coordinates, and that's going to be a shift to the right 1 unit. The plus 4 on the outside is going to be a shift up 4 units. And keep in mind, when you move left or right, these asymptotes that were on the y-axis, they're going to shift left and right with everything else. So you got to keep in mind where that asymptote is. Up and down won't affect the vertical asymptote. So those are your transformations. That's all I wanted to do here. I didn't want you to try to graph it, just list the transformations. Not going to do number 4 for the sake of saving some time. Number 5, some of y'all hopefully are already thinking this, but before you identify any shifts, you want to have a 1x. So I'm going to do a quick little bit of algebra. That's going to be negative log, and then I'm actually going to take a 2 out of the inside, which will leave me with 2 parentheses x plus 3. You have to have a 1x before you identify any shifts. And so if I were to strip away all my transformations, my parent function is just going to be log of x. And remember, if there's no base, it is understood to be base 10. So this will go through the ordered pair 1, 0 and 10, 1 before any transformations. Okay, now the transformations, I look and I see 3 of them. I see this negative, I see this 2, and I see a plus 3. So we have to identify what those 3 transformations are. 1, 2, 3. And the easiest one for me to identify is the shift, and I see a shift left 3. It's inside with the x, that's left or right. You can do the opposite of what it looks like. Now the negative on the outside, that's really a negative 1 times the log, and then I have 2 times on the inside. Remember, if it's inside with the x, it's going to affect the x coordinates, and you do the opposite. So if it says 2 times in the equation, then I will actually do the opposite. I'm going to divide my x coordinates by 2. And then the negative 1 times log, the negative 1 on the outside means it's going to affect the y's, and you do the same thing. So I'm going to multiply my y's by negative 1. So those are the transformations for number 5. So I'll divide x by 2, multiply the y's by negative 1. Then once I do that, I'll shift left 3. And that's how we would graph number 5. Yeah? Great. Okay, moving on. Let's look at number 7 on the back of this sheet. I want you to graph negative log base 3 of x, all plus 4. You need to identify what your parent function is, which I see log base 3. So I'm going to start with y equals log base 3 of x. And I know that that graph is going to go through the ordered pair 1, 0 and 3, 1. Whatever the base is 1, it's going to go through those 2 points. Then I need to identify my transformations. I see a negative. See this negative out front. And then I see a plus 2. The plus 2 is outside. That is not in with the x. That means I'm going to shift up 2 units. And that negative on the outside, that's going to multiply my y by negative 1. It's not inside with the x. It's on the outside, so it's going to affect the y's. And that's really negative 1 times the log of 3. So multiply the y's by negative 1. I'm going to do that with these ordered pairs. So I start with my original function, log base 3 of x. It goes through 1, 0 and 3, 1. And I'm going to start by multiplying my y's by negative 1. I'm not going to change my x's. I'm just going to multiply my y's by negative 1. So 1, 0, 0 times negative 1 is still 0. And 3, 1 is going to become 3, negative 1. And I'm actually going to graph those. So I have the ordered pair 1, 0, and then 3, negative 1. And so what this did is it flipped my graph upside down. And I still have a vertical asymptote on the y-axis. So I've flipped my graph upside down by multiplying my y's by negative 1. And then I need to take these points and shift each one of them up 2. So I'm going to go up 2 units. I'm going to go up 2 units. And this graph is going to come down following the vertical asymptote, hit that point, and then it's going to keep going that way. So that's what this graph is going to look like. Multiply the y's by negative 1, shift it up 2, and there's that log graph. Remember to follow that vertical asymptote. And the last one I wanted to do on this sheet is this one, number 9. Number 9, I'm going to skip number 8 just for the sake of saving a little bit of time. My base function, always have to identify that. It's going to be y equals log base 2 of x if we stripped away all transformations. And I know that's not your bell. Sit down. You can't go anywhere yet. That's order. Hey, geez, now they're going to be talking all the time. I have to pause this. This is a little bit annoying. Okay, I think it's calmed down a little bit. All right, so where was I? Log base 2 of x goes through 1, 0, and then it's also going to go through the ordered pair 2, 1, and we'll have that vertical asymptote. I just have to identify my transformations. So I'm looking here, I see a negative 2, I see it divided by 3, and I see a plus 1. So I see three transformations, and the easiest ones for me to identify are always the shifts, and that is a plus 1 on the outside. That's going to take my graph up 1, and we always do those last. That's why I list my shifts at the end. Now I see a x divided by 3. That's x divided by 3. That means it's going to affect the x's, but we'll do the opposite. So instead of x divided by 3, I'm actually going to multiply my x coordinates by 3. It's inside the parentheses. You do the opposite. Now negative 2 is on the outside, and that's negative 2 times the log. So negative 2 times, that's going to affect the y's, negative 2 times my y coordinates. I'm going to multiply my x's by 3. I'm going to multiply my y's by negative 2. Then I'm going to shift up 1, and I always do my shifts last. So let's do the multiplication first. My graph started with ordered pairs, 1, 0, and 2, 1. And I'm going to multiply my x's by 3, so it's going to be 3 times x. I'm going to multiply my y's by negative 2, so negative 2y. So 3 times 1 becomes 3. Negative 2 times 0 remains 0. 3 times 2 becomes 6. Negative 2 times y, negative 2 times 1 is negative 2. So in that step, I took care of my multiplication. Now I'm going to plot those points. 1, 2, 3, 0. And 6, which is a little bit off, but I can kind of eyeball that. Negative 2 is going to be here. And you still have that vertical asymptote on the y-axis. Still have that vertical asymptote on the y-axis. Then the last thing I have to do is take each of these points, and I'm going to shift them up 1 unit. So I'm going to take this one, shift up 1 unit. This one's going to shift up 1 unit. Now, if I take my vertical asymptote and I shift it up 1 unit, it doesn't go anywhere. So vertical shift does not affect the asymptote. Then my final graph, I'm going to follow that asymptote because it has been flipped upside down. That negative on the outside flips it. So it's going to come down, hit that point. Well, we'll pretend I hit that point. And it's going to keep going like that. That's our graph for number 9. Start with those 2 points, 1, 0, whatever the base is, 1, and then do the transformations. So there's that, and that's the graphing. The last thing I wanted to talk about is properties of logs, and this is another sheet that you have that was given to you today. And we're just going to fill in these blanks for properties of logs first, and then I'll show you how to use them in a second. Log base a of 1, regardless of what the base is, log base a of 1 is always 0. So that means if I ask you to tell me what is the log base 2 of 1, you know it equals 0. If I ask you to tell me what is the ln of 1, it's going to be 0. Any log of 1 is equal to 0. A to the log base a of m, it's like the a and the log base a cancel, and you're just left with m. You're just left with m. So that means that if I say what is 4 to the log base 4 of 6, it's just going to equal 6. It's like the 4 and the log base 4 cancel. It's like all that goes away, and you're just left with 6. Now the ones we're going to use most frequently, log base a of m times n. If you multiply inside a log, then you can split it into log base a of m plus log base a of n. Multiplication, you split with addition. If you're dividing, you'll split with subtraction. So log base a of m minus log base a of n. So if you're multiplying inside a log, you split with addition. Dividing inside a log, you split with subtraction. And then the last one, if you have an exponent on this little thing inside the log, then you can actually grab that exponent and you can bring it down front as a coefficient. You can move it down there. So this is going to be the exact same thing as r times log base a of m. So those are your properties of logs. There's one more that I wish I'd put in here. It's called the change of base. So just kind of scratch this in here somewhere. It's the change of base formula. And that works when you want to use your calculator. Like, let's say I asked you to evaluate log base 3 of 12. If I asked you to evaluate log base 3 of 12, the problem is on your calculator there's not a log base 3. There's a log, which would be base 10, and then there's an ln, which is base e, but there's not a log base 3. So to plug this in the calculator, the formula, you actually just do the ln of 12 divided by the ln of 3. And you'll punch that in the calculator and you'll get some answer. So the change of base formula is log base a of b is equal to ln of b divided by the ln of a. So I have a calculator right here, and I'm going to punch that in real quick. ln 12 over ln 3. Where's my ln button? ln 12 divided by ln 3. And you get 2.262. So you can punch weird bases in the calculator. You just have to use the change base formula. So using the properties that will turn up the most are these three. That doesn't mean you don't need to know 1 and 2, but numbers 3, 4, and 5 are the ones we'll use the most. And we're going to use those right here with numbers 1, 2, and 3. Numbers 1, 2, and 3. So number 1, log base 3 of x times x plus 6. What I'm wanting you to do is split these up into the sum or difference, which means add or subtract. And then I also want you to express exponents as coefficients. So any exponents you want to pull down as coefficients. So if you have log base 3 of x times x plus 6, then you split number 1 into log base 3 of x. And since it's multiplication, we will split that into addition. Log base 3 of x plus log base 3 of x plus 6. And that's your final answer. You can't do anything else with that. Number 2, log base 2 of something divided by something. If you're dividing, then you split it into subtraction. So log base 2 of x minus 3 minus log base 2 of z. And that's all you can do. That's all you can do. If it's subtraction, you split, or if it's division, you split with subtraction. Number 3, ln of x times that. So that's ln of x times means plus the ln of the square root of y plus 7. Yeah? So there it's split up. Now actually number 3, we're not through. We're not through because if you remember, I showed you the other day, I hate that little dotted box. Gotcha. Remember I told you the other day, the square root of something can be rewritten as something to the 1/2 power. So whenever we have radicals, it may not look like an exponent the way it's written, but this is an exponent, and we have to deal with exponents. So ln of y plus 7, ln of x, I can't do anything, but I can rewrite that as ln of, here comes another announcement. I'm going to rewrite it as ln of y plus 7 to the 1/2, and that will allow me to grab that 1/2, and pull it down front as a coefficient. So this one finally cleans up to ln of x plus 1/2 natural log of y plus 7. And that would be my final answer for number 3. Once you split it all up, that's what you're left with. Okay, good? Okay, good. So we have 1, 2, and 3 there. I do want to, let me go back to the sheet, because I want to do number 5. I want to look at number 5. I kind of wish I had some exponents in there. Oh well. So number 5, let me get this real quick. Hey, number 5. I want to split this up into a bunch of different logs. And the reason I want to do this one is because you're looking at it and you may see, all right, it's ln of x divided by something. So I'll split that into ln of x. And if it's divided by minus ln of y. And what you have to remember for this one is you do not just say plus ln of z plus 1. Even though that's multiplication down there, z plus 1 is still in the denominator. I'm still dividing by z plus 1. So since I am dividing by z plus 1, it's still going to be minus ln of z plus 1. So I completely split that up. Basically, anything in the top is a positive log. That's positive ln x. Anything on the bottom is a negative. So make sure that if you're dividing, everything in the denominator is being subtracted when you split it up. Everything in the numerator is being added, and that is a positive ln. If it makes you feel better, you can actually put a plus sign there. I don't care. So there's number 5. Let's see, number 7, 8, and 9, we're actually going backwards. We're going in the opposite direction. So we'll do these 3. We'll do these 3, and then we may just call it, I may just end with that. Where are we? 20 minutes. That's too long. All right, we'll do these 3 real quick. In the opposite direction, we are adding these. We're adding these. We want to combine them into a single logarithm. And so remember, if you're adding 2 logs, then that came from multiplication. So for number 7, I'll throw those together as log base A of, instead of x plus all that, it's going to be x times y plus 3. There you go. That's all you can do for number 7. Now number 8, I'm actually going to make this a 2-step process, because before I can combine them, I've got to get rid of my coefficients. I'm going to go in the opposite direction. I'm going to grab my coefficients and make them exponents. So 4 needs to come up as an exponent. 1/2 needs to come up as an exponent. I'm going to rewrite that as log x to the 4th minus log y to the 1/2. Yeah. And make those exponents, make those coefficients exponents. Then if we are subtracting 2 logs, you can combine that with subtraction. Wait a minute. Division. Haha. Subtracting 2 logs combined with division, so that will be the log of x to the 4th divided by y to the 1/2. And I'm okay if you leave it like that. Now some of y'all are probably thinking, y to the 1/2? Why would you leave it like that? You could write that as x to the 4th divided by, and the exponent of 1/2 is the same thing as a square root, and you can leave it like that. I know the Math League of America hates leaving square roots in the denominator, but I'm not a paying member of the Math League of America, so I don't care what they say. We'll leave that square root in the denominator. So that's how we'll combine number 8. Number 9, kind of the same thing. I do have a coefficient, so I want to bring that 2 up on my x, or up on my c to make it an exponent. So I'll have the ln of a plus 2 minus the ln of b plus, and I'm going to change that to the ln of c squared. So when I combine that, I'm going to have the natural log of, then I'm going to need a fraction bar because I do see subtraction there. So a fraction bar for the division. Ln of a plus 2 is positive. Minus the ln of b, so that means I need to divide by the b. And then plus ln of c squared, that's a positive ln, so that means it's going to go in the numerator. So c squared is going to go on top because it is a positive ln, and that's our answer. Roll it all together into one big log. Yeah. And then one mistake I made on this sheet, if you go down to the very last one, it's I made a little mistake on number 11, so just fix this. Fix number 11. I'm not going to do number 11. I just want to fix this mistake. The problem with number 11 is the bases are not the same on the logs. If the bases are not the same, the way this one's written, you cannot combine those. So just fix this. We'll, to make these the same, let's just change them all to log base 5. So instead of just having logs for those 2, we'll make it log base 5, x plus 7 minus 4, log base 5, y minus 3, minus 2, log base 5 of z minus 6. Because otherwise, this can't be done. So change it, forget that, change number 11 to all have log base 5s, and we'll deal with that later. And that's it, your homework. Obviously, I'm not here, so I'm not checking or taking up page 288. I'm sorry, that's BC. I'm not checking page 310, so you need to bring that Monday. You also need to have page 321 done by Monday. So do pages 310 and 321. You still have a lot of time to do it, and you may have some time in class tomorrow to do it as well. So make sure you bring your books tomorrow so you can have some time to work. And that's it. I'll see you all Monday. Have a great weekend.